Okay, this lesson, as you can see, is going to be about area scale factors. There's a rectangle, and if we double the lengths and we look at the areas of each rectangle, we might notice that although the lengths have doubled, the areas of the rectangles haven't doubled, they're 4 times. So when the length scale factor is 2, i.e. the length have doubled, the area scale factor, i.e. the area, is 4 times as much. Let's try that again, only this time we're going to treble those lengths. So 12 squared centimetres becomes 108 squared centimetres, and that's a scale factor of 9. So I'll add that into our table. And we're going to do it one more time. This time the length scale factor is 4, and the area is 12, but now it's 192, and that's 16 times. So in our little table, we can see when the length scale factor is 2, the area scale factor is 4. When the length scale factor is 3, the area scale factor is 9. And when the length scale factor is 4, the area scale factor is 16. That leads us to this result, that the area scale factor is the linear scale factor squared. So when you multiply the length by a number on a shape, the area is that number squared times as much. Let's see how this works. Here our length scale factor is going to be 3, so we're going to be trebling those lengths. So 5 becomes 15 and 4 becomes 12, and that new area now is 180. So how many times has the area been scaled up by? 180 divided by 20, that's a factor of 9 times. Let's see why this works. If we write 15 as 5 centimetres times 3 centimetres down here on our enlarged shape, and instead of 12 centimetres, we write that as 4 centimetres times 3. Then our new area, that's the base times by the height. But in that area, we can see we've got 5 centimetres and then times by 4 centimetres. So we've actually got 20 squared centimetres in there. And 20 squared centimetres is, of course, if you look, the original area of the smaller rectangle. In addition to that, we've got times 3 and times 3. So that is times 3 squared. So we can see that this times 3, which is the length scale factor, and this times 3, which is the length scale factor, they're multiplied together to give us 3 squared. And that's why the area scale factor is the length scale factor squared. And 180 was indeed our area. So let's apply this to a couple of examples. In example number 1, the length is 4 centimetres originally, and now it's become 8 centimetres. So that's a scale factor of 2. The area scale factor will be 2 squared, and that's 4. So the new area will be 36, which is the original area, times by 4, which is the area scale factor, and that's 144 squared centimetres. In example 2, to get from the big triangle to the small triangle, the length scale factor is from 10 down to 2. Okay, so that is 2 divided by 10, so that's a scale factor of 0.2. The area scale factor then will be 0.2 squared, and that's 0.04. So the area of the smaller triangle will be 40 times 0.04, and that's 1.6 squared centimetres. In this example, we're going to do this slightly in reverse because we're given the area, but we want to find a missing length. Well, if we square the length scale factor to get the area scale factor, then we square root the area scale factor to get the length scale factor. And that's what it's telling us up here, that the length scale factor is the square root of the area scale factor. So in this example, we want the area scale factor from 24 up to 96. That's a scale factor of 4. If we square root that, that will give us the length scale factor. So the length scale factor is 2. And therefore, to find x, it's simply 4 times 2, and that is 8 centimetres. Using the same result in example 2, the area scale factor, we're going from 40 down to 10, so that's a scale factor of 1/4 or 0.25. The length scale factor then is the square root of 1/4, and the square root of 1/4 is 1/2, so the lengths have been halved from 8 centimetres multiplied by 0.5 takes us down to 4 centimetres.